Assalamualaikum. And a very good morning to all
Walaikum
of you
assalam.
girls. Good morning, Miss.
Good morning.
Walaikum salam, miss.
How are you all?
Fine.
Alhamdulillah.
Fine. Alhamdulillah.
Okay. Now I can see some students are still joining. Okay, fine. Now, girls, tell me, do you remember in the previous class, means last week class, I was solving past paper with you? Do you remember?
Yes, miss.
Okay. So, when I was solving the past paper, we came to a certain year, right? Do you remember which year I was doing with you last? Is it 2013, 14 or 15?
14.
14. Okay. We have finished 14 or we'll be doing 14.
2014.
Okay. Yes.
We finished May, June of 14.
Okay. So we're supposed to go to October 11.
The first variant.
Okay.
31.
Okay. So I want to ask you one more thing. Did you try yourself doing some of the questions? Because you know, if we keep on doing everything over here, it will take a lot of time. As time is running so fast, I need to do the last chapter. That is, I want to do the last chapter. That is electromagnetism. Okay. So, but even though this week I will not start the new chapter, I want to continue with the past paper questions. But I want you to try yourself some of the questions. So, can I just skip 2014, the rest of the question, and go to 2015 now? But
Yes, miss.
Yes.
But there's some questions in.
yeah, if you get stuck, let's do one thing, Nashita, listen here. If you get stuck in any question, so later I can solve it again with you. What do you say? I think that is better, right? I want
Okay,
you
miss.
to, yeah, I want you to try yourself first. That is really important. Okay, so let me check 2015. If all of you go, I hope you have your past paper with you in front of you and the pencil as well as the calculator. You should have all of it with you. So let me see. I think I should go to 31 May to 15. Let me find it as well. Yeah. 31 May to 15. I can see question number, question number 8, no, it is electromagnetism. Okay, question number 9 we can do.
Yes, could you repeat the variant?
Yes, 31, May to 15. Question number 9 I want to do. Okay, all of you go to 31, May to 15. Question number 9. Okay. Now, let me start doing it. All of you look at this diagram. There is a circuit given to us. And in that circuit, if you just look at it, there are two parts of the circuit. In one part, you can see there's a symbol. This symbol actually you don't know. This is called a thermistor. As this is a combined question with the electronics, that's why that symbol came here. We'll be learning it in grade 10. But right here, you just remember it's a kind of a resistor which functions with the change of temperature. So we call it a thermistor. That is an arrow type of thing in the middle given. That is the thermistor. Then we have a permanent resistor that is 1000 ohm. And then we have decided if these two are in parallel and they are connected in series with another resistor that is having 500 ohm. Then they have connected all together to a source of 12 volt. Okay, guys?
Good morning, miss.
Yeah, good morning. Let's do that question. 31, May to 15, question number 9. Okay, now look at this. In part A, they are saying at a certain temperature, the thermistor has a resistance of 1000 ohm. Okay, fine. As I told you, that thermistor has a property that it can change its resistance according to the temperature. You learn all this in grade 10 electronics chapter, but right now, the one they gave, we can continue with that. Means they have given the resistance of this thermistor as 1000 ohm, and they said calculate the combined resistance of the thermistor and the 1000 ohm resistor. So, someone tell me what is the formula we are going to use here? First of all, they are connected in which type of series? Or which type of connection or circuit, we should rather say?
Parallel.
They are in parallel, definitely. So which equation are you going to use here?
1 by RP
That's correct. So
equals
1 by R1 plus 1 by R2. So quickly do the calculation and tell me what's the answer you're getting from there. And do remember to write down the equation. 1 by RP equals 1 by R1 plus 1 by R2. Then get the result in terms of a fraction, then reciprocal and get the value of R. And tell me what's the answer you're getting.
500.
That is 500. Fine. 500 ohm. I hope you have shown all the steps, especially the equation, then making reciprocal at the end. Definitely you got 500 ohm correct answer. So you have shown all the steps. Now let's go to current I. Now if you just remember, one part is a parallel connection, but it is connected to the other part in series, and all together they have connected to the circuit. So they are asking to calculate the current I. And we know that in a series circuit, current I remains the same. So to know the current I need to know the total resistance of the circuit. So how will you get the total resistance of the circuit now? You got a part of it only, that 500 ohm. So how to get the total resistance of the circuit, guys? Could you tell me how to join them or how to get it? Which equation will you be using here?
V is equal to IR.
No, dear, I'm going for current I. For current I need to know the total resistance. I'm asking you that one. How will you get total resistance? Because finally it is becoming a series circuit. So RS equals to,
RP plus RS, right?
yes, not RP plus RS. RS equals to RP plus R3 utility or R2 utility because we have two resistance. So RS equals RP plus R2. R2 is our 500 ohm, the one which is connected in the circuit. And RP itself you got 500. So altogether what is the resistance here? What is the combined resistance at this moment for the whole circuit? I said RS equals RP, the one you found in the part 1, plus R2. R2 is 500. So if you do 500 plus 500,
It's 1000, right?
1000 ohm. Yeah, correct. 1000 ohm. After that,
Miss,
yes, dear.
can you explain the first one? How we got it 500?
Okay. Now, as you know that we are going
The
to use
first
the,
resistance.
yes. We are going to use the equation 1 by RP equals 1 by R1 plus 1 by R2. Then it becomes 1 by 1000 plus 1 by 1000. Okay. So, yes, 1 by 1000 and 1 by 1000. And then it becomes 2 by 1000 if you add them. Then RP will become 1000 by 2 because we have to reciprocal. Isn't it? Okay.
Yes.
So after making the reciprocal, we got 500 ohm. Now for the second part, when I want to find out the resistance of the whole circuit, I have to go for, when we are finding out the current of the whole circuit, I need to know the resistance of the whole circuit. So for that, I'm using the equation RS equals to RP, the one I got on the first part, plus R2. R2 is our 500 ohm. If you just look at the circuit, you'll get it. If you add them, RP was 500, now it is also 500, becoming 1000. Now I'll go for the Ohm's law equation, V equals to IR and I equals to V by R. Someone do the calculation and tell me. V equals to IR, then I equals to V by R.
It's 0.012 ampere.
I think it is correct. Means we are using 12 divided by 1000. That makes us 0.012 ampere. Okay. Now, check the third part of the question. They say,
Miss, can you explain A3 again?
A3 I didn't do there, I'm doing now.
Oh.
A2 we did, V equals to
sorry.
IR. No, A3 will be doing now. They say the potential difference across the 500 ohm resistor. Now, as I told you before, that first you understand the pattern of the circuit. If you just look at it, the thermistor and 1000 ohm are in parallel. But that is again connected to 500 ohm as a series. So this whole thing is actually nothing but a series circuit. So we know that series circuit is a PD circuit, means potential divider circuit. It means that 12 volt will be divided into this parallel part and the 500 ohm according to them. So you just go for the equation V equals to IR, done, because I you got 0.012 multiplied by what is the resistance of this one? 500. So multiply by 500 and get it. Okay, so what's the answer coming up? V equals
6 volts.
yeah, 6 volt actually. It's voltage we're getting PD. So the unit will be volt, 6 volt. Okay, done. Now this part B at this moment I'll not do because it is about the thermistor formula or thermistor idea. We'll be doing it at grade 10 because after discussing about thermistor, you'll be able to understand this question. So leave part B now. Let's go to 32 major 15.
Miss, would you mind if you explain one more time?
Which one, dear? The part
A3.
Okay.
Yes.
Yes. In A3, as I said, this is actually nothing but a series circuit because 500 ohm is connected to this parallel circuit as series. So series circuit is a PD circuit or potential divider circuit. That is why we go for the equation V equals to IR. V is the potential difference equals to current, and current remains the same in series circuit. We know we got the current 0.012 multiplied by the resistance of this component, that is 500. That gives you the answer 6.0 volt. I hope it's clear until now. Okay. Now I want to move to 32 May June 15. Go to question number. Let me see what we have here. We got 8. Question number 8. That's a very smart question. All of you go to question number 8, 32 May June 15. Okay, all of you go to that question, then I'll start. First, I want you to read out and check. What do we have there? That's the 32 May June 15, question number 8. A small circuit is given. Okay, now.
Miss, question number?
8. That's the current electricity question. Okay, now look at this other question.
Sorry, Miss, can you repeat again?
32 May June 15, question number 8.
Okay, thank you.
You're welcome. Okay, now you just check the question. Did you notice a symbol is given?
Yeah.
On this circuit, a symbol is given. That symbol represents actually a heater. I'm not sure whether you drew all the circuit symbols that are given to you. At the end of the current electricity chapter, there you'll find this circuit symbol also. Okay, so you remember because all the symbols are quite different from each other. It looks like a permanent resistor, but it has certain divisions in the middle. That makes it as a heater. So you remember that it is not a resistor. Okay. Now I want you to read the question and tell me how will we get the first part. They said, look, figure 8.1 shows a circuit containing a battery of electromotive force 12 volt. Very good. And a heater of resistance 6.0 ohm. State what is meant by the electromotive force. I hope you have learned the definitions that I gave you for EMF, and it's a very important definition. Who can give me the definition? Yes.
Miss, you gave three definitions, right?
Yes, any of them you can write. So give me one of it, no problem. Anyone else can give me?
Well, it's the change in the concentration of charges across a device.
No, dear. Concentration of charge we didn't discuss. It is about like energy. Energy supplied to drive a single charge. You can say that 1 coulomb charge around the circuit. Isn't it? Do you have the notes in front of you? One of you open the note and check there. We wrote it. This is the energy. Electromotive force. It is actually providing an energy to drive 1 coulomb charge around the circuit. It's the energy given.
It is defined as the terminals of a source when it's not supplying current and not in a circuit.
Yes, you can write that also. No problem. No problem. I told you I gave you 3 definitions from them. One of them you will write it over here. No problem. Okay, guys. If it is done, then I want to move to question number B1. Okay. Yes. Let's go. They said calculate the current in the heater. So we have only one component, and as we learned before, ammeter has a very low resistance. We are not going to consider that one. So we'll just continue finding out the current is V equals to IR, then I equals to V by R. Okay, by using that equation, I want you to get the current and tell me what's the answer. See, they gave you 2 marks. So you have to ensure that you are showing the equation. For the equation, you'll be scoring 1 mark. Okay.
Is
Okay.
it 2 ampere?
Yes, correct. 2 ampere, correct answer. Okay, but I want to remind all of you one thing. I can see so many girls are coming very late. Why? We are at home and we know 9:30 is pretty good time. It's not 6:30, so you should not be late. Already I have finished one question and I'm doing the second one. So please make sure all of you are coming sharp 9:30. You should attend the class at 9:30. Okay. And as I told you before also, girls, that immediately the school reopens, we'll be having our final exam. So you can understand, last time what happened, some of the students couldn't score the pass mark. You have to go for the re-exam. So do remember all those consequences. So make sure you're studying at home and taking all these classes very seriously. Because we'll not get time after the school reopens to do all these questions within the school. Okay, fine, yes. Let's do it. So part B1, we got 2.0 ampere or 2 ampere we can write. Correct. State the name of the particle that flows through the heater. I want Ikra. Are you there? Could you give me the answer of this question? Ikra?
Yes, miss.
Yeah, could you give me the answer of this question? Do you have the book in front of you? Are you following? Yes.
Yes.
State the name of
Is
the
it
particle. I couldn't hear you.
electrons?
Yeah, electrons. That's the
Electron.
correct answer. Yes, very good answer. It's correct. Of course, we know that electrons are coming out from the cell and it is roaming all around the circuit and coming back to the positive terminal. We call it like that. Okay, fine. So all of you write down the word there, electrons. That's it. Now, they said on the figure 8.1, draw an arrow next to the heater. Just listen, check the question very carefully. Next to the heater symbol to show the direction of flow of these particles through the heater. Now, I want you to do it and tell me how will you give the arrow and from which direction to which direction will you give the arrow?
It's
Say. Could you be a bit loud? I can hear you.
From
No, yes, say no.
it will go down
from
right,
from the negative terminal left sorry, the right side,
right side, and then
draw arrow
Yes, means you'll be,
after the
the
negative.
arrow will be, let's see, they say beside the heater. So you can draw it left side or right side. But what will be the direction? Will it go from positive to negative or negative to positive?
Negative to positive.
negative to positive.
Okay, now I want to hear from Anup. Anup, could you tell me, because they said negative to positive, positive to negative, both the answer we got. I want
Negative to positive.
Okay. Now, so the correct answer is actually negative to positive because we learned that is the electron flow. And what do we call positive to negative? We have a different name for that, isn't it, girls? So what do we call that? Anuj,
Conventional current.
yes, good. Conventional current. So here they are asking us to show the electron flow. So definitely you can draw a single arrow beside this, right beside the heater or left side of the heater, but the direction has to be positive, sorry, negative to the positive because that is the electron flow happening. Fine, done. So let's go to the last part of the question. Calculate the thermal energy produced in the heater in 10 minutes. So what equation we are going to use here? Could you suggest me that equation?
V E is equal to VIT.
Correct answer. Okay. All of you use the equation E equals to VIT.
Can we also use V square by RT.
Yeah, you can use that. But do we have R? Yeah, we have R time. Yeah, you can use that. No problem. It depends on which quantity they have given to us. Accordingly, you can use. Your wish, no problem. If the values are given here, you can use it. And check and give me the answer. What's the answer you're getting over there?
It's 14,400.
4400
Okay.
joules.
Yeah. It means that 1.44 into 10 to the power 4 joules. Right? I hope you got the same answer.
Yes.
14,400 joules.
Yes, yes.
Okay.
Now I want you to go to 31.
Miss, in here, do we have to convert 10 minutes into seconds?
Definitely. You have to because you know that standard unit of time is only second, not minute. So whenever minute is given, we have to convert that one into second. Correct. Okay. Now I want to go to 31 October, November 15 verse. Let me see the question we have here. Okay. I think question number 8 we can do, girls. Could you go to page number 12, 31 October, November 15, page number 12, question number 8. Okay. All of you go to 31 October, November 15, question number 8. Okay. Girls, it's really surprising that I know grade 9, 32 students supposed to be in my class. And look at the participant, it's only 18. Why? So many students are not here. Do you have any idea about these students, girls? I'm not sure actually who's not here. I need to check all the names. Then only I can sort out. So many, I forgot the names also. I should have had the list with me. Okay, let me check who's not here. 32 is not an easy thing. See, and here I can get, I can see only 18 students are here. Okay, Shahad, I can see you today after such a long time. Shahad, how are you? You were not in my classes before. Shahad, could you hear me? I think she's not following my class, but she's here. Okay, now let me see. So many students are not here. I can't even remember all these. Okay, what is Afnan Laiba? I remember I haven't seen her for a long time. Girls, what about Afnan Laiba? Is she participating on the other classes?
No.
Then what
Sometimes.
Okay, but she's very irregular. I think I remember in the beginning 1 or 2 class I have seen her. After that, no idea about her, right?
She was present yesterday, but her laptop it lags a lot, so she's having a hard time joining the online classes.
Okay, no technical problem, right? But she's going to miss all the classes. Okay, and so many others. I can't remember the names. I need to pick out. Okay, fine. Now, guys, let's go for this question. Did you find this question number 8 that I referred now? Okay, now let's do it. I hope you got it by the time. They say a digital watch is powered by a 1.3 volt cell. The cell supplies a current of 4.1 into 10 to the power minus 5 ampere for 1.6 into 10 to the power 7 seconds. So they gave us second, we don't need to convert. Calculate, number 1, the charge that passes through the cell in this time. So, Nushat, Nosheen, could you give me the equation for this calculation? 8A, we need to find out the charge. We have the current, we have the time, as well as we have the voltage. So which equation I should use here?
V equals IR maybe?
IR, but we're not finding out the voltage here. We're finding out the current charge, the charge that passes through. So do we have an equation regarding charge with current, time, or voltage? Do you remember any?
I'm not sure. No, I don't remember, miss.
Okay, then I want Nafisa. Are you following my class? Nafisa, are you there? Could you give me the equation that I should use here to find out Q?
Can I?
Q equals to?
Right.
Not really. I think Darjian wanted to say something. Darjian, could you tell me what will be the equation?
Is it Q is equal to IT?
I think it is correct. Q equals to IT. Okay, we had this equation before. Oh,
It's Nafisa's microphone isn't working.
yeah, seems like that. Okay, fine, no problem. Let's do this. So our equation will be Q equals to IT. Today, Nashita's microphone is making huge noise. Why, Nashita?
I don't know, miss. I'm sorry.
I don't know. It's making huge noise. Okay, let me mute you. Okay, fine. When you need to question me, then you will unmute yourself. Okay, now listen. So what's the answer coming up, checkers? Q equals to IT. Do the calculation.
656 coulomb.
Fine. Good to that then. 656 coulomb. Don't forget C will be capital C because it's a unit. Q equals to IT, then 4.1 into 10 to the power minus 5 multiplied by 1.6 into 10 to the power 7. Altogether, it comes to be 646 or 56. No? Is it 46 or 56? 646 or 656?
56.
Okay, fine. 656 coulombs. Done. Now come to the next part of the question, part B, that is the resistance of the electrical circuit in the watch. Okay, so we have the voltage, we have the current, we have to find out R. So V equals to IR, R equals to V by I. Check, this is the answer. Or if you check, R equals to V by I, the voltage is given 1.3, I is given 4.1 into 10 to the power minus 5. Then check what's the resistance.
So, miss, can you say again the final answer of A?
A is 656 coulomb.
Okay.
Now you check
Miss,
say.
B comes
31.7 into 10 to the power of 3.
Okay, we'll not say 31.7. You can go for 3.17. Or you can leave the whole number. Okay, if you go for 3.17, then it becomes 3.17 into 10 to the power 4 ohm. 3.17 into 10 to the power 4 ohm. Did it match? Did it match with you guys?
Yes.
Okay, fine. Now, I want to go to part C of the question. They say the output.
Teacher, kilojoule or just joule?
Nashita, I didn't understand. Ask me.
My value comes 31,707.
I think that is correct. I just round it up, or I just went to the standard form. 3.17 into 10 to the power 4, I said. So isn't it the same?
But miss, we can also like write it as 32 kilojoule.
No, I'll not go to 32 because it is 700. Okay, we can go, but leave it. No problem. We can keep it in this way.
Okay.
Okay.
Miss, can you repeat A?
A. The answer of A.
Yes, miss.
That is 656 coulomb. Okay.
Can you repeat the equation and the calculation too, please?
Q equals to IT, and I was 4.1 into 10 to the power minus 5 in the first term, and time T was 1.6 into 10 to the power 7. So when you multiply, you'll be getting 656 coulomb.
Thank you.
Okay. Now, part B, I hope you have finished. Let's go to part C. They said output power. But let me remind you one more thing, that you have to make sure that you have learned all the equations, memorized it. Otherwise, you cannot pick a particular equation for a particular calculation. Now here they're asking for power. So what are the equations we have in power? Could you keep on saying one after another? P equals to, first equation is, anyone wants to say?
P is equal to VI.
Okay, then P equals to I square R. So many equations I've given to you. Okay, if it is VI, P equals to VI, we have the voltage and the current. I want you to check the answer from here. P equals to VI. So your V is 1.3 multiplied by I is 4.1 into 10 to the power 5. Take the minus 5. Sorry. So check the answer. What comes up? P equals to VI.
So 5.33 multiplied by 10 to the power of minus 5.
Okay, no problem. We can do this. And what's the unit for power?
Watt.
W, capital
Yes,
W.
capital W. That. Okay. So I want to go to now 32 May, June, sorry, October, November 15. 32 October, November 15. Okay, here actually we don't have any questions. We have one, but that is mixed with the electronics. So, okay, let's do one thing. Go to 32 October, November 15. Question number 9D only I'll do now. 9D. 9B and D we can do. Okay, all of you check because it is about the logic gate electronics, the one I'll be doing in grade 10 with you. But part B, 9B and 9D you can do with me now. So I want you to check. 32 October, November 15, question number 9B. Check. They say in the space below, draw the symbol for a fuse. Of course, you can do that. Do you remember what was the symbol? Who can tell me what was the symbol for a fuse that we have discussed before? What happened, girls? I want your participation.
A rectangle and the line from the middle.
Exactly, exactly. Very good. A rectangle, it will be just like a fixed resistor, but there will be a line all through across it. Fine. Then I want you to go to part D. If you just look at it, a small tiny circuit they have given to us. At the same time, on that circuit, one of the resistors value is given and the other one they are asking us to find out, which is unknown. Okay. Then, but they have given us one more thing, that is the combined resistance they have already given to us. Okay, the combined resistance is already given. So it means that it's a parallel circuit first of all. Okay, let me say, yeah, good morning, Sarah, but you are 30 minutes late, not even 30, 32 minutes late. So how will you get updated with me, with my class? Very bad. You have class at 9:30, so you have to come sharp 9:30. Okay, guys. Now, if you just look at the circuit, as we say, we have a formula that is 1 by Rp equals to 1 by R1 plus 1 by R2. Isn't it? So in this question, the value of Rp is given. You have to find out the value of this R. Okay, so how will you rearrange the equation? First, we'll write down 1 by Rp equals to 1 by R1 plus 1 by Ri. I'll write. Why? Because that is the value they gave to find out. So just rearrange the equation. Keep 1 by R in the left hand side. On the right hand side, it will become 1 by Rp minus 1 by R1.
Miss, can you repeat the variant? I'm sorry.
I'm doing 32 October, November 15, question number 9D. Okay. Welcome back, girls. Join me quickly because we are in the middle of a question. We need to complete it quickly. Okay, all of you. I hope you are in that same page, the one I was doing with you. That is, I told you 32 October, November 15, question number 9D we were doing. Okay, so let's see what is happening here. Okay, now I think the student. Okay. No, they say we have to calculate the unknown resistance R. Okay, so we'll be going for 1 by Rp equals to 1 by R1 plus 1 by R. Normally we write R2. Here I am writing 1 by R because the unknown resistance they gave a name R2. Sorry, R. So I'll be continuing with R. And as I told you, that is the unknown resistance we are going to find out. So let us take it to the other side, means in the left hand side. Okay, and then on the other side it will become 1 by Rp minus 1 by R1. Isn't it? Thus, if we rearrange the equation, the unknown quantity 1 by R goes to the left hand side. Fine. Now you substitute the value. Because 1 by RP,
1 by R minus 1 by 6.
yes, 1 by 4 minus 1 by 6. Then check. In division, what comes up? 1 by R equals to? Yes, very good. 1 by R equals to 1 by
1 by
12?
12.
Yes, then R equals to 12 ohm. That's it.
12 ohm. Okay.
Yes, fine. That's done. So I think, Alhamdulillah, we are done with 2015. I want to go to now. I think we should 16 we should do, because from then onwards we have a new syllabus. So let's go to, I hope you have 2016 with you. We'll be going to 31 May, June. Sorry, now onwards it will be 41. So 41 May, June 2016. 41 May, June 2016, question number 9. Wow, this is a very nice question. 41 May, June 2016, question number 9. 41 May, June 2016, May, June 16, question number 9. Okay, let's do it all of you. Did you find the question, girls?
Yes, yes.
Very good.
It shows a 12-volt battery, right?
Exactly, exactly. Along with that, 4 resistors are connected in different ways. Now, you just tell me A and B, how do they connect?
Series.
Very good. Then
Series.
Yes, A, B, and C.
Parallel.
Yes. Then A, B, C, and D.
Series.
Fine.
Series.
Fine. If you understand this one, you can carry out the whole calculation by yourself. So first you look at it, they say, calculate the combined resistance of resistor A and B. With the equation, you just quickly do it and tell me answer. With the equation, do you remember? Even if it is 1 mark, you have to show the equation all the time. Okay, I want to ask, before it was 18 students, now it became 17. Who left the class? Okay, Rahma, are you following me? Could you speak up? Yes, fine. Rahma, could you tell me the equation that you'll be using in A1? Okay, what is the equation, sir? For the series circuit, give me the equation, then I'll check whether it is correct or wrong. RS equals, you can't take that much of time. RS equals R1 plus R2. Everybody knows this equation. We used twice, I think, by this time, today's class. Okay, so what is the answer, girls? And did you know
12.
12 ohm? Because if you just look at it, on the top they say each resistor has a resistance of 6 ohm. So all the resistors that is connected in this circuits are all of 6 ohm. So you have to just add 6 plus 6 equals to 12. Okay, now they say resistors of A, B, and C. So what equation will you be using here?
1 by RP.
Very good. So 1 by RP equals to 1 by R1 plus 1 by R2. So for what is your R1 now?
12.
Very good. 1 by 12 plus 1 by 6. Because C is 6 only. Then check what's the answer coming quickly. I want to do
4 ohm.
4 ohm. Very good. I hope you have shown the steps. Because 1 by RP comes as 1 by 4. Isn't it? Just use the calculator and solve it. Then RP will become 4 ohm because it's going to be reciprocal. Okay. Now they said resistors A, B, C, and D. Again, RS equals R1 plus R2. This time R1 is 4 ohm and R2 is D itself is 6.
So it's 10 ohm.
Exactly, 10 ohm. Done. See, it's very simple. Once you understand the circuit, you can do it by all yourself. Okay.
What is R2?
R2 is D. And D is how much? All of them are of 6. So D is 6. So 4 plus 6. Altogether 10 ohm. Done. Shall I move to part B of the question? Okay, I can say yes. Okay, I'm going. Sadia, are you there? Sadia Hassan, I'm talking to. Are you there?
Yes, ma'am.
Did you complete the rest of the questions that I did with the students in the class? I'm not sure whether I have seen you in my previous class.
Yes. No, I didn't still completed all the work.
But you have to do it. Because I don't remember whether I have seen you before in my class. Okay. Now let's go to part B of this question. That is, they say part B1, the current in the battery. Okay, so we know the formula, V equals to IR, I equals to V by R. Now you have V that is given in the question, that is 12 volt. You have V there, and you have R. Right now you calculated the total resistance of the circuit, 10 ohm. So just divide and get the answer.
1.2 ampere.
Correct. And do remember this A will be capital, because whenever we write the unit with an alphabet, it has to be all capital. Done. Oh.
Miss, if you want to write the unit here, then we'll. It's just 1 mark here.
Then also, if the unit is not there, it will be, the whole mark will be gone, because there is no decimal deduction. Okay, that's why you need to be very careful. Okay, now go to B2. The energy transferred from the battery to the circuit is 50 seconds. In 50 seconds, sorry. So you have the formula. Same, energy E equals to?
VIT.
Yes, you can use that. Good. E equals to VI.
$720 joule.
722. Correct. Oh, now let's take 42 May June 2016. Let's go to question number 8. We can't do 9. We can do 10. All of you go to 42 May June 16, question number 10. Question number 10.
May June.
42 May June 16, question number 10. Okay. Now, Tazrian, if we just look, did you get the question? Tazrian, are you there?
Yes, miss.
Okay, fine. Now, if we just look at the circuit, there are 3 symbols given, X, Y, and Z. How do they look like? What are those actually, if we just look at that?
I think they're the heaters.
They are the heaters. Actually, these are the symbol of the heater, but they are calling them as hair dryer. Definitely they are hair dryer because we are going to heat it up, right? And of course, from the hair dryer, we can get the cold air and we can get the hot air. Definitely, most of the time, we use for the cold, hot air. That is why they don't have any separate symbol for hair dryer, but it is nothing but the symbol of a heater. Okay, fine. Now, come to this one. Here we have a key or a switch which has 3 positions, A, B, and C. All of you understand the circuit first, then we'll go for the calculation. Because without understanding it, you'll not be able to do anything. Then they say A, B, and C. Okay. Now, they say here, if A is given, all the heaters are off. You can see the circuit is not completed, so all the heaters will be off. But when you place it at B, only X heater is functioning. Isn't it, girls? Okay. Then at C,
yes.
Yeah, at C, when you place Y and Z, both are functioning. And all the heaters are having, means all these 3 heaters, that is their hair dryer heaters, they are having a power of 1000 watts. Fine. Now you check, they say here, heater Y and Z have equal resistance. They even mention Y and Z, but they did not say anything about X. Okay, we'll find it out. Then they said calculate. Okay, before that, girls, tell me one thing. If you generally check X, Y, and Z, if B and C points were together, so how did they connect each other? X, Y, and Z. If B and C are together,
Parallel?
They are in parallel, definitely. Good answer. X is separate in one branch, Y and Z are in series. Again, they are in parallel with X. Okay, fine. Now let's come to this one. Calculate the resistance of the heater X. Now, if you just look at it, when you are connecting the switch to B, only X is going to function. Isn't it, girls? Girls, all of you follow the circuit?
Yes.
Yes, fine. So, what do we know about the equation which is relating the voltage, resistance, and power? Do you remember any equation that relates?
P is equal to V square by R.
I think you relate this one because voltage is given 240 and the resistance is given 1000 ohm. Sorry, 1000. No, not resistance. They have given us the power. Okay.
Power.
Yes. So you write the equation. All of you first write down the basic equation. P equals to V square by R. Then make R as the subject. R equals to V square by P. Am I right, girls?
Yes.
Okay. So substitute the value. V is in your diagram 240. So 240 squared divided by what is the what power is given 1000. Fine. So 240 squared divided by 1000.
It's 57.2.
57.2.
Sorry, 6. 57.6.
57.6.
7.6.
Okay, fine. 57.6. What's the unit? No.
Ohm.
Yes, ohm, because we found resistance. So 57.6 ohm. That. Okay. Now they're asking us to find out the resistance of the heater Y. But here we have to remember one more thing, that the resistance of the heater Y, if I want to find out, I have to make sure that Y and Z are using series connection. Okay, so as we know that both of them are having the same power, so we can expect that in series, they are going to enjoy the voltage into half because it's a series circuit. Series circuit is a potential divider circuit, isn't it, girls? So let us first find out what is the voltage experienced by one of these heaters, Y or Z. So V equals to 240 divided by 2. This step you have to do first. Otherwise, you cannot use the equation R equals to V square by 2. So your voltage is coming out 240 divided by 2 is 120 volt. Guys, did you understand why am I dividing 240 by 2?
Yes.
Because both of them are having. Okay, I'll tell you again. Listen, as you can see on the diagram that if the switch is at C, Y and Z are connected in series. So we know that in series circuit, the voltage will be divided among these two components. And as also they mentioned that they have the equal resistance. So definitely it will be equally divided. That's why without any hassle, I am straight dividing by 2 to get the voltage. That is 240 by 2 equals to 120 volt. Then you can go back to the previous equation. P equals to V square by R, R equals to V square by P, and get the answer. R equals to V square by P. So now your V is 120 square divided by 1000. Okay, what's the resistance coming out for?
Is it 14.4?
Do you have any other number after it or it's just 14.4?
It's just 14.
Miss?
Okay, is it recurring?
No.
Okay, then leave it. 14.4 ohm.
Yes. Can you repeat the equation after 120 volt?
Okay. You know the equation that we used in A, same equation. P equals to V square by R. Rearrange R equals to V square by P. Because all of them are having the same power.
Right.
Now, I want all of you to go to C, part C of the question. They say the current in heater Z when the switch is in position C. Now, you remember one more thing, girls, that when you are giving a connection in series, the whole power will be included. It's not that you can only use the Z here. Like in series, the resistance gets increased, power also gets increased. So you have to add together. So first you write down PS, S means series, PS equals to, or P, just write down straight P. P equals P1 plus P2. It means that if you add some appliances in series, their powers will be also added. Okay, it will get increased. So power P equals to P1 plus P2. Even though they are.
So it will be 2000 watt.
Yes,
right?
fine, very good. Okay. Then you go for P equals to VI. From there you can find out I. The equation is P equals to, yes dear?
The first equation, did you say it's P equals to P1 plus P2?
Exactly. Because it is connected in series, so the power has to be increased here. Then P equals to VI.
Miss.
Yes, dear. What's the answer you found? I equals to?
Wait, the answer is 8.33, right?
It's recurring. Okay, no problem. Then 8.3 ampere.
Miss, wait, but I got it in a different way.
Say.
I got it by 1000 by 120.
Why will you do that? Okay, let me say. 1000. Okay, 120. Okay, fine. You can do it on that way also, no problem.
Miss, would you mind if you repeat?
Yes, I'm saying again, listen. As I told you, when two components are connected in series, their powers has to be increased, just like resistance. So you will write down P equals P1 plus P2. Okay, equals to 2000 watts here because both of them are having 1000. Then go to the equation P equals to VI. Okay, I equals to P by V. Here the power is 2000 divided by the voltage is 240. Equals, you got, I think 8.33 something. 8.3 ampere. No problem. Okay. Now let's quickly go to 41 October, November 16. Okay. Here I can see I have a question.
Miss, can you repeat?
Which one? Yeah, 41 October, November 16. Question number 8 we should do. Yeah, question number 8 we can do. 8 and 9 actually we can do both. Let's do quickly 8. 8 and 9 both.
Miss, can you repeat the variant?
41 October, November 16. 41 October, November 16. Question number 8, 9 both I want to do. So let's start with question number 8. A battery is made up of 8 cells in series. Each cell has an EMF of 1.5 volt. The battery is connected to one 8 ohm resistor for 40 minutes. Calculate the EMF of the battery. So I want someone to give me the answer. EMF equals, what will you do?
1.5 into 8.
Correct. Because here they are all connected in series. So 8 multiplied by 1.5, take the answer.
It's 12, right?
12 volt. Volt. Right on the volt. Now they say, calculate the energy transferred from the battery in 40 minutes. Okay. So we know the equation E equals to, we used it before, VIT, right guys? So do we have I here? I think we don't have I. Do we have? No, we don't have
V
I.
square by RT.
Yeah, we can do that. V squared by R into T. Yeah, we can do that. So do that. V squared by R multiplication T. So we have the V square is 12. 12 square divided by R. R is 8 ohm multiplied by the time. That is 40 minutes. So 40 multiplied by 6. Okay, they gave us 4 marks. See, that's it. Okay, guys, do one thing. As it is 4 marks, I want you to show the steps of the equation. First, all of you write down E equals to VIT. Because the equation that you told me, that is the Girard equation. Remember, I did a calculation that then I got this equation. So 4 marks, so we need to show that step. So all of you write down the basic equation E equals to VIT. Then write down V multiplication. In place of I, you'll be writing V upon R. Then multiplied by T. All of you listen to me carefully. E equals to VIT. Then V multiplication V by R, because in place of I, I'm going to substitute V by R. Then multiplication T.
Wait. What, Miss? V multiplication V by R?
Yes, multiplication T. Okay, then the next step you substitute all of that. Then it will become 12. Multiplication 12 by 8, because R is 8 for you. Then multiplication 40, multiplication 60. Okay, then check the answer, because they gave us 4 marks. So I'm thinking that we should show the derivation of the equation. Because we don't have any straight equation like V square by R into T. The first equation is VIT, that is why.
It comes 720 joules.
Are you sure?
No, 43200 joules.
I think it is correct. I think Nashita didn't multiply it with 60 because you did not convert it 40 minutes to second. Okay, so that is done.
Wait, what's the final answer again?
43200.
Yeah, yes, 4 means 43,200 joule. 43,200 joule. If you want, you can go to the standard form of your wish. Then it will become 4.32 into 10 to the power 5 joules. Got it? Okay. Now check the next part of the question. C. Describe the energy. Yes, dear.
I got 432.
Only. How?
Yes.
Look, first it is 12 multiplied by 12 by 8, that is V by R, multiplied by 40 minutes, multiplied by 60, because minute should be gone to second. That's it.
Miss, wait, why is it 12 in the beginning? I wrote 1.5.
But did you understand? It's not 1.5 there because total EMF, all those cells connected together to make a battery. That battery is connected to this resistor. So you cannot use 1.5.
So 1.5 into 8.
You did the calculation in A, you don't need to show it again. Straight you'll go for 12. 12 multiplication, 12 by 8, as I said, V by R, 12 by 8, then 40 into 60.
Oh yes, I got it.
Good. Let's go to C. Describe the energy changes that take place during the 40 minutes. Okay. Here, if you just look at the circuit, just imagine the circuit. From the battery, one change of energy will be going on, and inside the resistor, another change of energy will be going on. So 2 marks they give us, so we have to discuss in both the cases. So in battery, what change is going on, girls? Inside the battery, what type of energy change is occurring?
Chemical energy to electrical energy.
Yeah, you can say that, definitely. In battery, you have to mention it, where it is happening. In battery, chemical energy to electrical energy. And what about the resistor? Anyone knows what is happening inside the resistor?
Electrical energy to heat
energy. Yeah, fine, correct. Reem, I can see that Reem joined our class right now, 2 minutes before my class is going to end. Reem, this is really bad. You forgot the timing of the class. Yesterday I gave you a reminder in the group. That's really bad.
It's already.
Yes,
Miss, do we have to mention also the energy change that takes place in the resistor?
yes.
Electrical energy.
Yes, because they say here energy changes take place during the 40 minutes. So it's the full circuit, right? If you just mention the cell, that is inside the cell. But what do we have outside? We have another resistor, which is going to complete the circuit, isn't it? That is why you have to say both the things. Okay. Now, all of you come to question number 9. I will give you the hint.
Can you repeat one more time?
In battery, chemical energy to electrical energy. In resistor, electrical energy to heat energy. Because the resistor is going to be warm or hot after a certain time of electricity passing through it. Okay.
Miss,
now, yes, dear.
Is there any equation in 8a?
No, it's just a multiplication. Remember, in our class we had the formulas. We don't have any formula. Just you have to multiply and you have to keep in parallel. It will remain the same. We just discussed together like this. Okay. Now, in question number 9, I want you to. Yes, dear.
The time is up. It's 10:30.
I know. Yeah, I'm going to release it as soon as possible. Look, question number 9 is your homework. Tomorrow, I want to start from question number 9. You take the question because the same question came in 2019 one more time. So you can understand how important this question is. This is your homework. Tomorrow, I want to check from this question. Okay, guys? And all of you, just a reminder again that you have to join my class sharp 9:30. What's the use joining the class 2 minutes before the class is going to end? So please make sure tomorrow, right on time with your past paper, because this week also I'm going to do the past paper. Next week, inshallah, I'm going to start the new chapter, that is electromagnetism. Okay, girls? I hope you are following my class, doing all the questions with me. Please do that, otherwise you will be in problem. Okay, see you inshallah tomorrow, guys. All of you stay safe and pray for all of us. Okay,
Same to you, Miss.
thank you.
Assalamu alaikum.
And
Thank you.
walaikum salam. Bye for now.
Assalamualaikum.
Walaikum salam.
Assalamualaikum, Miss. Bye. Thank you.
Bye.